In a previous lesson, we discussed determining trig function values for a right triangle where we were determining the values for one of the two acute angles, either the angle theta here or potentially this acute angle here. In this lesson, we'll talk about calculating trig function values when the angle is obtuse, such as this case, or when the angle is a right angle or a multiple of 90 degrees, such as 180 or 270. So in general, we've learned trig function definitions for sides labeled opposite, adjacent, and hypotenuse. Those same definitions can be translated into relationships with the variables x, y, and r. In this case, x is synonymous with adjacent, y is synonymous with opposite, and r is synonymous with hypotenuse. So for example, we know sine of theta as opposite over hypotenuse. Well, in terms of these definitions, the sine of theta would be y over r. Cosine's adjacent over hypotenuse, that would be x over r. Tangent is opposite over adjacent, that's y over x. And you can see for a triangle here how those sides are labeled. This angle that we're looking at, this angle theta, positive angle because it's counterclockwise. You can see that's an obtuse angle, but you can see that to determine these side lengths x, y, and r, if I choose a point on the terminal side of this obtuse angle, then that point has x, y coordinates. Those determine the value of x, or in other words, the value of the adjacent side, the value of y, or in other words, the value of the opposite side, and then the r value I could determine with the Pythagorean theorem, knowing these legs. In the coordinate plane, while x and y can be positive or negative depending upon which quadrant, for example, with this point xy, the x value would be negative, while the y value would be positive because we're in the second quadrant. So x and y will change positive to negative depending upon the coordinate. The r value is always positive. So once again, these definitions, you can just see the comparison. For example, tangent y over x, or tangent opposite over adjacent, depending upon which definition you're using, but they are equivalent expressions. So here's an example. Let -4, -3 be a point on the terminal side of theta. Evaluate the 6 trigonometric functions of theta. So here's my angle theta. Well, first of all, let's locate this point, -4, -3. So -4, -3, there's the point. I draw a ray to that point, and that determines the x value here, that's -4, and the y value here, that's -3. And I can see based on this right triangle that the r value would be 5. It's a 3, 4, 5 triangle. Remember, the y and x values will be positive or negative depending upon the quadrant. The r value is always positive. Once I have all three sides labeled, then once again I can determine all 6 trig functions simply by the definitions. Sine is y over r, so that would be -3 over 5. Or tangent is y over x, -3 over -4, and the negative signs would cancel and I'd be left with 3/4. So I can determine those 6 trig function values. And really those values correspond to this angle theta, which is clearly an angle larger than the angles we were determining trig function values for previously. This is an angle greater than 180 degrees, but we'll talk more about that. So once again, an example, point -9, 14. Use the given point on the terminal side. Evaluate the 6 trigonometric functions. So all I would have to do, I can determine the y value here from the point, that's 14. The x value is -9. the r value I would get with the Pythagorean theorem, square root of 277. Once I know those three values, x negative 9, y 14, r square root of 277, I can determine all 6 trig function values. Once again, you can see we're really determining these trig function values for an obtuse angle, an angle that's greater than 90 degrees. The same type of problem. The distinction here is they don't actually plot the point for me, but that's easy enough for us to do. Plot 710. Well, 710 would be located here in the first quadrant. The 7 identifies the x side, the 10 identifies the y side, Pythagoras identifies the r value, and then I can define the 6 trig functions based on x, y, and r. For example, cosine, which is adjacent over hypotenuse, or in other words, x over r. Cosine would be 7 over root 149, and then when I rationalize, I would get 7 root 149 over 149. The next type of angle we're going to look at, these are quadrantal angles. And quadrantal angles are those angles in standard position where the terminal ray lies on one of the axes, positive or negative x, or positive or negative y. So for example, here you can see if the terminal ray lies along the y-axis, standard position means the initial ray is here along the positive x-axis. If the terminal ray lies along the positive y-axis, then this angle is 90 degrees. That's a quadrantal angle. Or if the terminal ray lies here along the negative x-axis, that's an angle of 180 degrees. That's a quadrantal angle. Or here you can see an angle of 270 degrees. Any multiple of 90 is a quadrantal angle. So quadrantal angles determining the trig function values, well, the values, once again, will depend upon x, y, and r. But I have to think about what happens as the point, or the r ray, the terminal ray, moves towards one of those axes. So for example, here I can see a triangle where I have an acute angle theta here in standard position. And that angle looks like it's roughly 45 degrees. Now if I begin to increase that angle and I start to bring it towards 90, I can actually see what's happening to my sides. As I bring that angle towards 90 degrees, that terminal ray, I can see that the y value has increased while the x value has decreased. R has remained the same, it's simply the radius of the circle. And if I keep bringing that in this direction, the x value is going to continue to get smaller. And the y value continues to get bigger. And really what the y value is doing is it's approaching R. So what happens when this terminal ray finally gets to 90 degrees, the x value is 0, and y and r take on the same value. And these are the three values I would use to determine the 6 trig function values. So x is 0 and y is equivalent to r. And you can follow a similar process to determine these relationships. So if the terminal ray lies here along the negative x-axis, the values for x, y, and r, y is 0 and x is the opposite of r. Here you can see the three values for x, y, and r, and also here. And I'm going to pause this presentation and continue in another video.